Hello viewers, in this presentation we explain the properties of Cobb-Douglas production function. The Cobb-Douglas production function is Q is equal to a k power alpha L to the power 1 minus alpha, where Q is output, K is capital factor and L is labor factor. A and alpha are constants and alpha lies between 0 to 1. Property 1. The Cobb-Douglas production function is linearly homogeneous function, that is lambda q is equal to A into lambda times k power alpha into lambda times L power 1 minus alpha. Now, the right hand side portion, that is A into lambda times k power alpha into lambda times L power 1 minus alpha is equal to, after removing this bracket we get A into lambda power alpha into k power alpha into lambda power 1 minus alpha into L power 1 minus alpha. Then that is equal to lambda power alpha plus 1 minus alpha into a k to the power alpha L to the power 1 minus alpha. Thus lambda times of a into k to the power alpha into L to the power 1 minus alpha, but a k to the power alpha L to the power 1 minus alpha is nothing but q, so we get lambda q. Thus we get here the output q has increased by lambda times, that is lambda q, as a result of increase in capital K and labor L by the same constant lambda times, that is lambda k and lambda L respectively. Property 2. The average productivity of capital and labor depends on factor ratio. The average productivity of capital APK is defined by APK equal to Q by K, that is A k alpha L to the power 1 minus alpha divided by K, so we get A into L by K power 1 minus alpha. The average productivity of labor APL is Q divided by L, so we get A into K by L power alpha. So both APK and APL are functions of factor ratio, that is L by K or K by L. Property 3. The marginal productivity of capital and labor depends on factor ratio. The marginal productivity of capital, that is MPK, is defined by partial derivative of Q with respect to K, that is del Q by del K. Here the value of Q is A k alpha L to the power 1 minus alpha. So after differentiating it we get this and this, and we get finally alpha into A into L by K power 1 minus alpha. Similarly, marginal productivity of labor, that is MPL, is MPL is equal to 1 minus alpha into A into K by L power alpha. Here both MPK and MPL are functions of ratio, functions of factor ratio, that is L by K or K by L. Property 4. Cobb-Douglas production function satisfies the Euler's theorem, that is Q is equal to MPK times of K minus MPL times of L, that is marginal productivity of capital multiplied by K plus marginal productivity of L multiplied by L. Therefore, mpk into k plus mpl into L is equal to, here we put the value of mpk. So, this is the value of mpk multiplied by k plus this is the value of mpl multiplied by L. So, after multiplying this k, we get alpha into a k alpha L to the power 1 minus alpha plus 1 minus alpha a k alpha L to the power 1 minus alpha. Here a k alpha into L to the power 1 minus alpha is nothing but q. At first we get the common, we take the common, and then we take then we put the value, that is we got q, because alpha plus 1 minus alpha is equal to 1, and this a k to the power alpha L to the power 1 minus alpha is nothing but q. So, finally we get q is equal to mpk into k plus mpl into L. This means that the total product is exhausted if factors are paid equal to their marginal productivities. Property 5. The slope of isoquant is negatively sloped and convex curve, that is dk by dl is negative, that is less than 0, and d square k by dl square is greater than 0, that is first order derivative of k with respect to L is negative, and the second order derivative of k with respect to L is positive. Therefore, dk by dl is nothing but minus mpl by mpk, that is ratio of marginal productivity of labor and marginal productivity of capital. So, dk by dl is nothing but negative of the ratio of marginal productivities of the factors. So, here we have put the value of mpl, that is the value of mpl, and this is the value of mpk. After simplifying, we get minus 1 minus alpha by alpha into k by alpha. Since alpha is lies between 0 to 1, so that is why 1 minus alpha is positive. So, because of this negative sign, we get here, that is less than 0, and d square k by dl square, again the derivative value of already second order derivative of k with respect to L, we get the d by dl or derivative value of minus 1 minus alpha by alpha into k by L. So, here this is the value of dk by dl, here we have put. So, after differentiating it, we get this is the constant, k by L is a ratio of two functions. So, we use the question rule of differentiation. After applying this question rule of differentiation, we get this. Again, putting the value of dk by dl, we get this, and we get this by taking the common k in numerator, and here this minus sign has been cancelled by this minus sign. So, we get positive sign here and positive sign here, and at the same time the alpha is lies between 0 to 1. So, 1 minus alpha is positive. So, all these factors or all these terms are positive. So, that is why that is greater than 0. Here d square k by dl square is found greater than 0. Since dk by dl is less than 0 and d square k by dl square is positive, the slope of Cobb-Douglas production function is negatively sloped and convex curve. Property 6. The elasticity of factor substitution of Cobb-Douglas production function is equal to unity, that is sigma is equal to 1. The elasticity of factor substitution is defined by theta is equal to proportionate change in factor ratio, that is k by L, divided by proportionate change in marginal rate of technical substitutions between labor and capital. So this is the definition of elasticity of factor substitution. So that is nothing but derivative value of factor ratio, that is k by L, with respect to marginal rate of technical substitution between labor and capital, multiplied by marginal rate of technical substitutions divided by factor ratio k by L, and that is equal to derivative value of factor ratio with respect to factor price ratio PL by PK into PL by PK divided by k by L, because marginal rate of technical substitution between labor and capital is the ratio of factor prices. So marginal rate of technical substitution is equal to PL by PK. So here we have put the value of marginal rate of technical substitutions in terms of price ratio. So at the equilibrium point of a firm, we get the slope of isoquant is equal to slope of isocost line. So that is nothing but dk by dl is equal to minus pl by pk, because slope of isoquant is dk by dl and slope of isocost line is minus pl by pk. But dk by dl in this example we get minus 1 minus alpha by alpha into k by l, and that is equal to 1 minus pl by pk. After cancelling the minus sign we get, and taking this 1 minus alpha by alpha into the right hand side, we get k by l is equal to alpha by 1 minus alpha into pl by pk. So differentiating k by l with respect to pl by pk, we get alpha by 1 minus alpha. So therefore sigma is equal to dk by l by dpl by pk into pl by pk divided by k by l. Here we put the values of dk by l with respect to pl by pk, that is 1 minus alpha plus 1. Here pl by pk, again we put the value of k by l, that is alpha by 1 minus alpha into pl by pk. After cancelling these two terms, again cancelling these two terms, we get 1. So the elasticity of factor substitution is equal to unity, that is sigma is equal to 1 of this production function, because this Cobb-Douglas production function is a linearly homogeneous function. So these are the properties of Cobb-Douglas production function. Thank you.